Hello everyone. So today let's solve the problem 300 longest increasing subsequence, right? So this was sorry. Yeah, let's see what the question states here. So we are given an integer array nums, you can clearly see here, right? So we need to return the length of the longest strictly increasing subsequence. We have to, what we need to return here, we need to return the length of the longest strictly increasing subsequence. When I hover over subsequence, what it says here, this one, a subsequence is an array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Without changing the order of remaining elements, this is very important, right? So here the longest increasing subsequence they have given here is 2 3 7 1 0 1. So this has to go in this order itself, right? So you cannot consider 7 and you cannot consider 10. You can consider 10 and then you can consider you cannot consider 10 and then you can consider 9. No, uh, the previous number, see here, the first number, this has to be smaller than the next number. So this number has to be smaller than the next number, 7, right? So this is the subsequence length. We have to return the length of the longest strictly increasing subsequences, right? So that's what they have given in the subsequences definition as well when I hover over it, right? So this one we have 10 9 2 5 3 7 1 0 1. This one, this is fine. So 2 we can consider this one, because if we consider 10, next we have to go with this one 18 and then 101, which will not lead to the this one longest increasing. You can just add that one, right? So then if we have to go with 9 9, we will be going with a 10 as well as after 10. So we can't go with a 10 9. After the 9 we have to go with a this one, what do we call, uh 101 basically. After 9 we have to go with a 101. So see here as well, after 10 we don't have any other number that is greater. We have to go with the 101, 101 plus 10. So we cannot go with the 18 as well, sorry. 10 and then 101, that is greater. 10 101, if we go with it will be 111, right? So this one, suppose if we consider 2, after 2 we have 3. We cannot consider 5, because if we consider 5 this will not be the this one. Again it will be it will not be longest strictly increasing subsequence. You can just add, because we will be going with 2 3 here. 3 is fine. Then we'll be going with a 7, which will give us 10 actually. 10 plus 2, 12, 12, then 101. 101 plus 12 is nothing but uh, 113, right? So this is the longest increasing subsequence, right? So this one, therefore we have to go with the length 4. So we don't have to worry about the sum here, right? Sorry, I thought we have to go with the sum. I got confused here. So this one we just have to go with the longest increasing subsequence. That's it. So 10, after the 10, we can just go with the 101. So this will be length basically 2, right? So then if we consider 9, again we have to just go with a 101, right? So this will be of the length 2 as well. If we consider 2 here, 2, and if we can skip this, we can skip this one, right? This is fine. 2, 3 we can go the next largest, 7 we can go, and 101 we can go. So this is one of the this one. See here, let me write it over here. So first if we consider 10, it will be 10 followed by 101. If we consider 9, then 9 followed by 101. If we consider 2, then we can just go with a 10 5. 1 second. So here we can consider this one 2 5, next increasing we have 5, 7 we have here 101, right? So this subsequence also we can consider, and or we can just go with the 2. We can just ignore this 5 actually, and we can just go with 2 3 7 101 as well, right? So next, if we consider from this one, what do we call, from 5 from 5 actually, this will be 57101. This is also one of the subsequence, and then we can just go with a 37101. That also we can do, right? Then finally we can just go with this one, yeah, 7 2 two digits also we can go with, right? So 2 101, 3 101, this one, 7 101, right? Then finally we can just go with the one digits as well. So I'm not showing this one, two digits. So this is not possible. We already have the two ones, right? So we already have the this one, the numbers with the length 2. So I don't have to show this one, 2101. So this one we have to go with the 3 anyways. After the 2 we have to go with the 3 anyways, so we can't directly hop into 101. That is also that is fine. So we can just go with this one, 7101 as well, right? So this is also one of the things, and 18 is one single thing that you can consider. All the single numbers also you can consider 10 9. So this is fine. So this is of the length 2, this is of the length 2, 4 here, this one 3, yeah. This one is also 3, 2, and 1. You can consider any number, 1, 10, 9, 2, this one, all are of the length 1. That also I can consider, but we have to go with the longest increasing subsequence, right? So here in this case, what is the longest increasing subsequence? So this one, 257101. This is of length 4, and 237101. This is also of the length 4. We can just either consider any of them, right? Either of them. In simple terms, you can just consider 2 37101, 25701, right? 2 35101, sorry, 37 actually. Yeah, 237101, which is of the length 4, or you can just consider 25701. Either of them works actually. Both are of the length 4, and this is the longest, this one, increasing subsequence, right? So yeah, we have to return this one, the length, not the this one. What do we call the digits actually, right? So this is the output. So here we have 010. So let me go with 010323, right? So here this is fine. So we can just go with 0 1 2 0 1. We can just skip this one, 0 1, this one 2, then 3, right? So again the 4, right? So this is fine. You can just check. So here all the digits are same. When all the digits are same, we can just go with only 1, right? So the next increasing number is not present at all, so we have to go with the 1 in that case, right? So they have given wonderful examples just for the sake of understanding. Initially I got confused, man. I thought we have to sum up. Sorry. This is fine. Yeah, now all we have to go with here is longest increasing subsequence. That's it, right? So now let's discuss the approach followed by the complexities, and then let's write the code. So first let's discuss the approach. So as I've said, we will be going with a DP to solve this problem, right? Dynamic programming. So we will be making use of 1D DP to solve this particular problem, right? So let's see the first point. The first point, let's consider the numbers, this one, right? So this one, what are the numbers we have? Let me write this one. This is fine. 2 9, 10 9, 2 5, 3 7, 101, and 18, right? So this is fine. So next step, let's move on with the next step here. Let's initialize the DP array, DP of the same length, where DP of I stores the length of the longest increasing subsequence that is ending at I, right? So this is the second step, DP array of same length, right? So let's initialize the DP array of same length, right? So this is fine. The third step would be, so we have to iterate from I to we have to iterate I from 0 to n minus 1, right? So for each I, we will check all the j from 0 to I minus 1. That's what we will do. But that's what we will be doing basically. This is nothing but the iteration. So I'll just write here iteration, right? So this is fine, man. Basically, in simple terms, if nums of j is less than nums of I, then we will be updating the dp of I, that is equivalent to the max of dp of I, comma dp of j plus 1, right? So dp array builds, initially it builds how many numbers are there, there here? 1 2 3 4 5 6 7 8, right? So initially we'll be filling this one with a 8 ones actually, 4 5 6 7 8, right? So this one, second step, we are going with the dp of the same length, right? So this is fine. Now after processing step by step every individual this thing digit. So after processing, it becomes 1 1 1. So this is 1, this is 1, this is also 1, 2 we have individual. So next we can go with the 2, right? So next we can go with a 2, right? So 2, this is fine. Next also we can go with a 2, then 3, then 4, 4, 4 because this one, what do we call? Delete this one, yeah. 2, 2, we know. 3, I have showed this one, right? 3, we can consider 57101, right? For the 2, we can just go with a 10 9. This was, sorry, 10 101 and 9 101. 4 4 is nothing but for the 2, this one. Uh, Either it is 2 3 7 101 or 2 5 7 101, right? Uh, yeah, sorry, 2 3 7 101 or 2 5 7 101. We can just consider any this one. It is considering both here. At the end, the largest one, we get the this one, longest increasing subsequence length, basically, right? So we have got 4 4 as the longest increasing subsequence here. So we will return this one as output, which is equivalent to the output that they have mentioned for the example one within the question, right? So our approach works absolutely correct here. So we can just make use of the DP for this, right? So DP works absolutely correct here, the approach basically. So now as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexity. So what will be the time complexity here? Because of n square. So why it is big of n square here? The time complexity is big of n square because we will be making use of the two nested loops over n, right? So we will be making use of the two nested loops over nums, right? So this is fine. So what will be the space complexity here? Space complexity would lead to big of n as well because we'll be going with the DP array that stores the longest increasing subsequence lengths, right? So this will be the space complexity. The time complexity and the space complexity for the code that we'll be writing in the future would be big of n square as well as the big of n respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So this will be simple. First, we'll be making use of the length of the nums everywhere. So I'll just do one thing. Let me assign that one to the variable and here. This is fine. Yeah. Now let's do one thing. Let's go with the this one. What do we call? Length of the longest increasing subsequence that is ending at I. So let me initialize the DP right here. So this one will be int DP equals new int of uh, n1. This is fine. Yeah, next let's go with the minimum length of the longest increasing subsequence, that is nothing but 1. So I'll just go with for loop here, int I equals 0, I less than n, so this will be I plus plus. This is fine. Let me go with here uh, dp of I, let me write it here itself. Dp of I, let me initially go with the, let me assign this one to the 1, right? So minimum length of longest increasing subsequence is always 1. Now, as I've said, we'll be going with the this one, right? So what do we call nested loops, right? Uh, Time complexity during the this one discussion of the complexities, basically I said we'll be going with the nested loops, right? So it was time complexity would be big of n square. So we have discussed the approach as well. So we know that we'll be going with the two for loops here because for this one for loop for each element, another for loop to check all the previous elements, right? So I'll just go with for here int I equals 0, I less than n. So this one will be I plus plus again. So within the for loop, let me give one more for loop here. Int j equals 0, j less than I, j plus plus. So this is fine. So within the for loop, what I'll do, so if increasing, meaning if nums of j is less than nums of I, if we have got the increasing number next to the number, then we have to update the longest increasing subsequence length. Suppose we have 1, 2, 3 increasing order, right? So one to the next to one, we have 2. In that case, it is increasing the number next to the previous number, current number, suppose it is 1, and the current number has to be less than the next one. Here in this case, 1 2 3 we have 2, 1 is less than 2 and 3 is less than uh, uh, 1 is less than 2 and 2 is less than 3. Basically, if it goes on increasing, then we have to go on updating the this one, longest increasing subsequence length, right? So let's write the simple if condition first. So I'll just go with if nums of j, if it is less than nums of I, then what we need to do? So I'll just go with the dp of I equals math dot max of this one dp of I, comma dp of j plus 1. So this is also fine, man. Yeah, so we are just updating the longest increasing subsequence length here. So I'll just come out of this one entirely. Now let's do one thing. Let me assign max length. So this is nothing but the result variable, max length to 0. Then let's go with the for loop here. This one int I equals 0, I less than, we are considering n, right? I plus plus. So this one, let me go with max length equals uh math dot max. This is fine. Math dot max of max length along with a dp of I. This is fine. Yeah, we are just going with a maximum longest increasing subsequence. Finally, let me return max length. Right, so this is fine, man. Let me format the code once and let me hit the run button. So this is it for the code. Simple one, right? Very simple one. Wrong answer. What's the thing that we have done wrong here? Let's check the code. Nums of length. This is fine. DP new int of and we have this is fine. We are getting instead of one, right? This is fine. DP of I, we have set this one to one. Then we are going with the nested loops here. Mm, this is fine. Then I j plus plus. This is also fine. Nums of j, if it is less than nums of I, yeah, this is fine. If it is increasing, then we have to update the longest increasing subsequence length. Nothing but dp of I, we are going with a math dot max of dp of I and dp of j plus 1. So this is also fine, man. Then what's wrong here? Between 16 and 20. Let's check. 16 and 21. Max, and we have set this one to 0. We are going with a I equals 0. This is fair. I less than I plus plus. This is also fine. Max length, we are assigning this one. Okay, we are going with math dot max of max length. This is fine. And dp of I, this is also fine. Then what is wrong here? Just give me a second here. So let's do one thing. Here in the line number 11, we have to make change, I believe. So this is whole plus 1 month. dp of j plus 1. So let me remove the square brackets here. So this is the only mistake, I believe. I hope so. Let me run this one. Now, yeah. Now the sample test cases are getting passed, right? So let me hit the submit button now very quickly. So I can clearly see here all the test cases are getting passed, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.